Hello everyone. Today we are going to solve LeetCode problem number 2523, which is marked as medium on LeetCode. The problem is given two positive integers left and right. Find the two integers num1 and num2 such that left less than equal to num1, less than num2, and less than equal to right. Both num1 and num2 are prime numbers. So basically you have to find two prime numbers between this range left to right such that num2 minus num1 is the minimum amongst all other pairs satisfying the above conditions. Right, you have to find two prime numbers between this range left to right such that num2 minus num1 is the minimum, the difference is minimum, and then return num1 comma num2 as a pair as your answer, right? So if I give you an example, suppose left is 10 and right is 19. So you have to return two prime numbers between this range 10 to 19 such that the difference between those two prime numbers is minimum. So in this example, let me explain this example. So in this example, what are the numbers, prime numbers between 10 to 19? 10 to 19, the prime numbers between the range 10 to 19 are 11, then 13, then 17, then 19 itself. Okay, these are all the prime numbers between 10 to 19. So here you have to select two prime numbers whose difference are minimum. If you select these two numbers, suppose 11 and 13 you selected, so here the difference is 11 and 13, the difference is 2. Suppose you have selected 13 and 17, here the difference is 4. Suppose you have selected 17 and 19, here the difference is 2. So 2, 4, 2 are the differences, so minimum difference is 2. If two differences are equal, here you can see this difference is also 2, so two differences are equal, so you have to return this one because this comes first. This one is less than this pair, so you have to return this as answer. So my answer will be 11 comma 13, right? You can see here also the answer is 11 comma 13. So this is how you have to solve the problem. So in order to solve the problem, we first have to find the all the prime numbers between this range. So first step will be calculate all the prime numbers between the given range. Between the given range, you have to find all the prime numbers between the given range, and then you have to find the two prime numbers, then find two prime numbers that satisfy the given conditions. Okay, so how do we calculate all the prime numbers between the given range? So you would probably know that for finding list of prime numbers between the given range, there is a theorem called sieve of Eratosthenes, right? If I write here sieve of Eratosthenes theorem. So this what does this theorem says? Let me explain this. This theorem says that suppose you have a range. I'm taking an example. Suppose between 0 to 10, you are trying to find all the prime numbers between this range 0 to 10. So this theorem says that initialize a boolean array like this. Initialize a Boolean array. If I write the array, initialize a Boolean array from 0 to 10 index. Okay, 0 to 10, 0, 1, 2, 3, 4, 5, 6, 7, 8. Sorry. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? Let me give the indexes here. So basically this one is 0, this one is 1, this one is 2, 3, 4, 5, 6, 7, 8, 9 and 10. So you have to initialize a Boolean array. First all the numbers, all the values will be true. So let's write true here. This is a Boolean array, right? So all the values will be either true or false. So first initialize all the values with true. All the that means at first all the values are prime, right? Assume that all the values between the range 0 to 10 are prime. So let me write true everywhere. Okay, now we know that 0 and 1 are not true, are not prime numbers. So I'll update this one. I will not initialize these two with true. Instead I will write false here, because these two numbers are not uh, prime numbers, right? Prime numbers starts from 2. In case if you don't know what is prime numbers are those numbers that is divisible by 1, either 1 or the number itself. Like 2 is divisible by 1 or 2. Like 3 is divisible by 1 or 3, right? That means there will be only two factors of that number, prime numbers. Okay, so this is my first stage. Okay, first stage. Then iterate from 2 to 10, and if the current is if the current number is like 2 is prime number, you know that 2 is prime number. So make multiple up to all the multiple up to as false, because if 2 is prime, then 2 into 2, that is 4. 4 cannot be prime number, and 4 is not prime number, we know that. Next, 2 into 3 is 6 2 will be not prime number, and 2 into 4 is 8 2 will be not prime number, and 10 will also not be my prime number. So I have to what is the eraser? I have to update this multiple up to as false, because this cannot be my prime number. This is false. 6 2 will be false. Next 8 will be false, and 10 will be false, right? So for 2, the 2's multiple all are set to false. Next come to 3. 3 is a prime number. Okay, and 3's multiple, all the multiple of 3 will be set to false. Okay, 3 is true, so 3 into 2 is 6 will already false. 3 into 3 is 9 is 9, I have to set false. Okay, now there are no numbers. Next come to 4. 4 into 1 is 4. 4 is not prime. Next come to 5. 5 is prime number, so update 5 into 2 equal to 10 as false. It is false. Next come to 6. 6 is not prime number. 7 is prime number, so 7 into 2 14. It is not here. So you can see by this I can the values where true is present, the indexes will be my prime number. So what are the prime numbers in 0 to 10? You can calculate here from true. This one is true, this one is true, next this one, and there are none. So my answer will be, for the prime numbers between 0 to 10 is, what are the prime numbers? The prime numbers are, first one is true, 2, next is 3, next is 5, and next is 7. Okay, so this is my answer for this one. So by this you can you have to calculate uh, all the prime numbers between a given range. This is called sieve of Eratosthenes. Let me box this. So this is a very important theorem. You have to know this, and we will code this. Okay, calculate all the prime numbers between the given range, and then find two prime numbers that satisfy the conditions. Okay, so we have found this list 11, 13, 17, 19 by the help of sieve of Eratosthenes. Now we have to calculate two prime numbers. If I continue with the previous example, like 11, what were the my prime numbers? 11, 13, next 17 and 19. So how do we calculate my answer from here? Okay, iterate from here, like I check if the previous one, and calculate the difference with the previous one. So if I start from here, there is no element from here, so I have to start from here. So start from this 13 and check the difference. First initialize a minimum difference equal to, I'll set this as infinity, right? I'll set this as infinity and check, calculate the current difference. Current difference means my I is here, right? And I is here at 13. Now calculate the difference. My difference will be equal to 13 minus 11. 13 minus 11, which is equal to 2, and update the minimum difference. My minimum difference will be what? Minimum of infinity and 2, that is 2. And so my minimum difference will be 2, and update the answer, or you can say result, as 11 comma 13, as 11 comma 13. Okay, this is the first iteration for I equal to 1. This is for I equal to 1. I equal to 1. Now when I becomes 2, I equal to 2, right? That is when I is here. When I is here, calculate this difference, 17 and 13. What is the difference? Difference is 17 minus 13. 17 minus 13, which is equal to 4, right? So my minimum difference, now between previous minimum difference was 2 and current is 4, so between 2, what is my minimum difference? 2. So this is not my minimum, right? That is my current difference is not less than my minimum difference, so I will not update my result. Next, when I will be 3, next I is equal to 3. Okay, next I is equal to 3, that is when I comes to at 19. Next, the difference 19 minus 17. So my current difference is 19 minus 17, which is equal to 2, and my minimum difference is equal to, previous one was 2 and current is 2, so my answer will be 2. Minimum difference will be 2. But you can see that here also for 17 and 19 the difference is 2, and for 11 and 13 the difference was 2. So in the example you have to return the 11 and 11 comma 13. Here you can see 11 comma 13 because it is the lowest. You have to return the lowest one. 11 and 13 is lowest, and here two possible answer is there, 11 13 and 17 19. So you have to return the lowest. In the problem it is saying, you can see that here, if there are multiple, right, if there are multiple pairs satisfying these conditions, return the one with the smallest number one value, right? So you can see here there are two possible answer. What are those? 11 comma 13. 11 comma 13, and one is 17 comma 19. um, uh, there are multiple answers, so you have to return those in that pair whose num1's value is lesser. So here 11's value is lesser, so I have to return this as my answer. This will be my answer, this will not be my answer. So this is how you solve this. We'll code it. So let's code this approach. So what do we have to do? We just have to do this. Calculate the prime numbers between this range with the help of Eratosthenes. With the help of Eratosthenes, and find two prime numbers that satisfy the given conditions. Okay. So I will create a vector of Boolean. I'll create a vector Boolean on these primes. These primes which will basically store from 0 to the maximum range. All the numbers if the number is prime or not, like RIGHT plus 1, comma, and this side. So in this vector, and from here I will call my function Eratosthenes. Eratosthenes, and I will pass my right the maximum range I will pass, and this will give me the all the values from 0 to right that are prime numbers. I will get my all the values in this list. Okay, now what will I do? I will traverse this array for int I equal to left. I will be less than my is primes. Sorry, I will be less than equal to right, and I will be plus plus. If my current element is is prime, my current element is true, right? If my current element is prime, then I will let me create another vector of integers called prime primes, right? So if the current number is prime, so I'll push my current number to my primes vector. So push back my current number, which is I. Okay. So from left to right, I've got my numbers that are prime, and the numbers that are prime, and among those numbers, I have to uh, find those pairs, that is those two numbers whose difference is less. So I'll again traverse for int I equal to 0, and I should be less than my PLI primes dot size, and I will be plus plus. Okay, so let me create a variable called min diff. Min diff will be equal to in maximum, in maximum, and uh, let me define another variable called difference. This will basically store my current difference. So this will start from I equal to 1, and the difference will be primes primes of I minus primes of I minus 1. This is my current difference. So if my current difference is less than my main difference, so I will update my main difference will be equal to current difference, and I will create another. Let me create another vector called vector of integer result, and whose size will be 2. Size 2, and value will be -1. of result of 0. The first value will be the primes of I minus 1, and the second value, will be primes of I. And at the end, I will return my result. I will return my result. Now, let's write this Eratosthenes function. Uh, I'll divide this Eratosthenes function here. So this will basically return a vector of booleans. Vector of booleans, and this is integers. This is integer. Now, let me create a vector. Vector of boolean called is prime, whose size will be right plus 1, comma, and everything will be initialized to 2. At first, everything is prime numbers, and my is prime of 0 will be equal to false, and my is prime of 1 will be equal to true. So false, because 0 and 1 is not prime numbers, that's why these are false. Now I start from 2. I will be less than I will be less than is prime dot size with plus. Now, if my current number is prime or I is 2, so not I. Maybe I got index I. If my current number is prime number, then for int j equal to 2 multiplied by I, uh, and j less than is prime dot size on j equal to j plus or update all the multiple of I by false. So is prime of j will be equal to false. And from here, the return is prime. So in this is prime will be returned to here, and here it will be stored. So let's run this approach. It should be accepted. Okay. Use of undeclared identifier of is prime in the line 8 if is primes. Okay, this is primes. Is primes in the forms. Let's run this. I think this should be accepted. Okay, this is accepted. Now let's submit this. Is it able to pass all the test cases? Yes, it is passed. So this is how we can solve the problem. Thank you.